So given the point C is on line 1 with coordinates 1, 0, 1, D is on line 2, parameter mu equals -2, and we need to find the area of the quadrilateral CDBA. So the first thing we should do is find out the coordinates of D. So we know it's on line 2, which is given by this vector equation here. So we'll just plug in mu equals -2 to that vector equation and get D. So know that D is equal to -1, 0, 2 plus -2 times 5, 6, 2, and working that out, we're going to get -11, -12, and -2. Okay, so we've got D. So what might be a good idea is if I just bring up all the other coordinates and direction vectors that we know of so far. Okay, so we know the coordinates of A, B, C, D, and P, and we've got the direction vectors P to A and P to B. So because we're trying to find an area of this quadrilateral, CDBA, we've got a bunch of coordinates and direction vectors. We're most likely going to need to take the cross product of some of these vectors and use that information to find the area of that quadrilateral. So it's not always clear exactly which vectors and direction vectors, etc., that we need to take the cross product of in order to help us find this area of this quadrilateral here. So what can help is if we just do a rough sketch and try and roughly plot where some of these coordinates might be on those lines, it can make it much clearer how we can find the area. So let's just bring up a rough sketch of those two lines. So we've got line 1 and line 2 here. So line 1's in the blue, line 2's in the magenta. And we know that they intersect at the point P. So if we label that there P, and we know that that was 4, 6, 4. And we'll just note that I've drawn these in 2 dimensions obviously, but they are in 3 dimensions, these lines are. So just imagine that we're looking straight down onto the XY plane and that Z axis is coming straight out of the page. So if we just look at where the X and Y coordinates are of each of the vectors, they can give us a rough idea of where we should be plotting them. So if we look at P there, 4, 6, 4, if you want to plot A, well we know it's on line 1 and it's got X and Y coordinate 3 and 4. So that's going to be to the left and down a bit of P. So we'll just plot it somewhere here. Now this isn't to scale or necessarily very accurate at all, but will give us an idea of what we're dealing with. Okay, and B, -1, 0, 2, we know that is on line 2. So if we come to line 2, well, it's going to be to the left of P a bit and quite a bit down. We'll just plot it, say there. Again, it's not to scale. So B, we know is -1, 0, 2. Let's make that a bit neater. -1, 0, 2. C, we're told is on line 1, and that was 1, 0, 1. It's going to be down and to the left of A somewhere, so we'll just put it there. And point D is going to be quite far along to the left and quite far down. We'll just plot it somewhere there. Okay, and that was -11, -12, 2. -11, -12, 2. Okay, so the area we want of this quadrilateral CDBA, if we just draw some rough lines, so C, D to B to A. Okay, so that's the area we want. So if I just highlight that in yellow, that is the area we are looking for. So what we can notice is we've got a couple of triangles and we know how to find the area of them. It's half the magnitude of the cross product of the 2 direction vectors that make up that triangle. So if we look at triangle PCD, so that would cover this red area and the yellow area. So I'll just highlight that red area there. So triangle PCD, that covers the yellow and the red. So we've worked that area out. Then we need to think, well, how can we take out, just find the yellow area? So we can just take out that red area, which is triangle PAB. So if we work out the area of those two triangles, we'll be able to find out the area of our quadrilateral. And what I'll do now is I'll just bring up a picture of what this actually looks like in 3 dimensions. Not that you'd be expected to do that for an exam or know what it looks like or anything. This rough sketch is absolutely fine, but it sometimes just helps to visualize what exactly is going on. So it's going to look something like that. So we've got our line 1 and line 2 shown there in the blue and magenta respectively, and we just want that yellow area. So that's the quadrilateral CDBA, and the points are marked there. So that is actually an accurate representation of this problem. Okay, so let's start finding the area of some of these triangles. We'll start by finding the area of that red triangle, which was PAB, and then we'll do the area of the bigger triangle PCD. So if we scroll down just to get some space, then the area of the triangle PAB is going to equal half the magnitude of the cross product of P to B cross with P to A. Okay, now it doesn't matter if we went P to A cross P to B, or even took the direction vectors of A to P and B to P, etc., because we're taking the magnitude, so any negative signs, etc., it's not going to matter. So we'll just keep it simple. We'll just do these direction vectors here, P to B and P to A. So that's equal to half the magnitude of, or P to B, -5, -6, -2, cross with P to A, which is -1, -2, -1. And working that out, so if we just cross out that first line there, -5, -1, we just focus on here, -6 times -1, which is 6, minus -2 times -2. So we're going to be left with 6 minus 4, top part, and then the second part, or the y vector, we start with the negative, and then so we cross out that middle row, -6 and the -2 there. So -5 times -1 is 5, so we're going to have 5, and then minus -1 times -2, so -1 times -2 is 2, 5 times 2, which is 2. Okay, and then the z coordinate, or the z part of this vector, cross out that last row, and we're left with -5 times -2, which is 10, and then minus -1 times -6 is 4. So we're going to be left with 10 minus 6, and that magnitude. So working all that out, it's going to be half the magnitude of 2, -3 and 4, which equals, so it's going to be half, or the magnitude, take the square root, or 2 squared plus -3 all squared plus 4 squared is equal to half square root of 4 plus 9 plus 16, and that equals 29 over 2, root 29 over 2. Okay, so that is the area of that red triangle, PAB. Okay, so now we can try to work out the area of triangle PC and D. So to do that, we're going to need to know the direction vectors of P to C and P to D. So if we just scroll down a bit more, so we've got some space. Okay, so we know that P to C, well, that's going to be equal to point C minus P. So we'll just make clear that's a direction vector. And C was 1, 0, 1. P is 4, 6, 4. And working that out, we're going to get -3, -6, -3. And P to D. Well, this is going to be D minus P, and the point D was negative 11, negative 12, negative 2, minus point P 4, 6, 4, and that is equal to negative 15, negative 18, negative 6. Okay, so now we can work out our area of our triangle. So the area of the triangle PCD was half the magnitude of the cross product of P to C and P to D. Okay, so that is equal to half the magnitude of, so P to C, negative 3, negative 6, negative 3, crossed with negative 15, negative 18, negative 6. Okay, so if we go through that process and work that out, then it's going to be half the magnitude of, I'll just write the answer down here, 18, negative 27, and 36. Okay, so we can actually got a common factor of 9 in all these, the x, the y, and the z coordinates there. So if we factor out a 9, that is going to equal 2, or 9 over 2. And then we're going to get 2, negative 3, and 4. So that's going to equal to 9 over 2 times the square root of, we're going to have 2 squared plus negative 3 squared plus 4 squared. So that's equal to the 9 over 2 times square root of 4 plus 9 plus 16, which equals 9 over 2 times root 29. So now we've actually got all the information we need to find the area of our quadrilateral CDBA, because you know that the area of that CDBA, that was equal to the area of the triangle PCD, which was on our picture, which included the yellow and that red area, minus the triangle PAB, which was just the red area, and that is equal to 9 over 2 times root 29 minus, and PAB we'd found out was 1 over 2 times root 29, which equals 8 over 2 times root 29, and that is equal to 4 root 29, and it's an area, so we'll just say units squared. Okay, so that is the area of the quadrilateral CDBA.